So let's suppose that f of x, hey, we're going red, is 3x cubed plus 7x squared minus 5x plus 1. And we're going to find part A, f prime of x, the first derivative. So this is what we've been doing already. What is the first derivative? 9x squared, minus 5. Second derivative. What'd you get? Good. Third derivative. Fourth derivative? 0. Notice for a polynomial function, eventually you're going to hit 0. And notice it's one more derivative than the what's it's called? Degree. One more derivative than the degree. So if we have a 6th degree polynomial, then it'll take 7 derivatives to get to 0. It's like that whole Tootsie Pop thing. How many licks does it take? 7 derivatives. G of x is 5e to the 3x. I want you to find g triple prime of x. So to find g triple prime, what do you need to find first? G prime and g double prime. Very good. What is g prime? Right, so I'm going to write it out. The 5 doesn't leave, it doesn't go anywhere. E to the 3x, and then times the derivative of the exponent, which is 3. So the 3 and the 5 are on the outside, so they can get together to make 15. And now for the second derivative, that 15 sticks around. E to the g of x you get back, and then you multiply by the derivative of the exponent, which is 3, again. So notice, all you have to do is just multiply the previous one by 3. Okay? Now, that's because the exponent is linear. If it was anything else, we'd have much more work to do. So 15 times 3 is 45. And just to write everything out, the triple prime where we want, you get back what you start with the 45 and the e to a function, and times the derivative of the exponent is still 3. So 3 times 45 is 135. H of x is, I don't know, let me think of a completely original function that we didn't see twice today. X squared e to the x. I want you to find h double prime of, oh, that's too nice, h triple prime of x. If you're doing it right, it should hurt. What's the first derivative? Correct. Notice, e to the x's is self-replicating. You always get one back. And notice x squared e to the x, the first term in the derivative is itself. No, we should not. Because then when you do the product rule, then you'll have first, second, third. And then, correct. It's easier if you leave this alone. So here's the deal with the shortcut. It's not much of a shortcut. When we take the second derivative, we have to take the derivative of each part. Notice this part, the x squared e to the x, is the exact same as the original function. So when we take the derivative of this guy, we get back these two terms. One more time. So x squared e to the x plus e to the x times 2x. So this derivative goes right here. But now we have to take the derivative of e to the x times 2x. So this itself is its another product rule. So this will be the new first, this will be the new second. So it's plus the first, e to the x, times the derivative of the second, plus the second, times the derivative of the first. So we did another product rule. Are we done? No. But notice, this does clean up a little bit. Because how many 2x's e to the x's do we have? How many 2x's e to the x's do we have? 2. So if you simplify before you take the derivative, a lot easier. So we can rewrite this as x squared e to the x. That's the first term. Well, the second term is now 4x e to the x. Uh-oh. Oh, my hand was in the way. I can't put my hand on the board. Plus 2 e to the x. So now we can just take the derivative of that guy. Notice the first term, x squared e to the x. That's our original function. So its derivative is this guy, the x squared e to the x, plus e to the x times 2x. So we just did this guy right here. Plus is this plus. What rule do we need for 4x e to the x? Just the product. We don't need the chain. Got product? It's backwards. If you say it 3 times in a mirror, it comes and attacks you. No? First, 4x times the derivative of the second. What's the derivative of e to the x? Plus the second, e to the x, times the derivative of the first. 4. And now we have to take the derivative of 2 e to the x. What happens to that 2? Stays, times the derivative of e to the x. And now you're done. This does clean up. For instance, these two can combine as 6 e to the x. These two can combine as 6x e to the x. But you can leave it alone.